Hi everyone, today we'll discuss about how we increased our revenues within our product called Offerwall using Spark, XGBoost, and statistics. I'm Daniel, I'm a data scientist here at Fiverr. Alongside me is Michael, he's the data science and BI lead. Let's go over the agenda. We'll start with a brief overview about Fiverr, what we do, who we are, then we'll dive into the business use case, then we'll explore a solution both in terms of what we looked for and what we actually implemented. Then we'll walk you through our A/B testing mechanism, what we test and how we test things. And then we'll share some main insights that we had and learned during this journey. Let's start with a brief overview about Fiverr. Fiverr is an ad tech company. We sit in the domain between the advertiser and the publisher, which is the app developer. We're a global company. As you can see, we're spread all over the world. We're publicly traded, and most importantly, we are hiring, so we can check our careers within Fiverr.com. We're a big data company. As you can see, we have tons of events being processed and passed through our system each and every single moment. For example, we have 25 billion auctions per day, 200 million DAOs, which are daily active users, 300 terabytes per day, which makes it a lot of data. Why are we here? Marshall, our algorithm, which we'll discuss about today, increased the Offerwall this product's revenues by 11%. In terms of absolute revenue, this means a lot of money. Let's discuss about our business use case. Offerwall is a product which is integrated within a user's application. Basically, this product contains like offers in which user can perform, execute, and then proceed within some kind of a game. So let's say you're a user playing some kind of an application, and now you're stuck. You don't have any currency, any life in order to proceed to the next phase. What you can do is actually complete some kind of an action. And once you have done this action, you can get your in-app currency and thus proceed within the game. So what's the motivation within this kind of a project? First, we'd like to increase our user engagement. We can do it by offering or showing the relevant users the relevant ads. Second, we can maximize the revenues for our clients, which are the publishers, and of course to Fiverr itself. What are the challenges in this kind of a project? First, our data is too big within this product for ordinary frameworks. We're talking about the scale of hundreds of millions of events. An event can be, for example, an impression, a click by some kind of a user, etc. Also, another great challenge is that we're living in a delayed feedback environment, meaning that a conversion, the actual task a user will perform, can take up till a few minutes or up till a few hours or even a few days. So that's another great challenge.
Okay, cool. Thank you very much, Daniel. I'm gonna elaborate a bit more about the delayed feedback or the delayed conversions, how we call it in the offer. So let's take three scenarios, three users, user A, B, and C. All of them clicked on a task on January 1st. User A took 2 days to complete the task, and the value for us of the task was $2. User B took 9 days to complete the task, and the value was $3.50. And user C actually took 30 days to complete the task. However, it was worth a lot to us. It was worth $40. Cool. So now we can actually try to think about it in an algorithmic way. So we are looking at this as the multi-arm bandit problem. The multi-arm bandit problem is when you are in a casino and you have several slots and you want to lever the slot that will maximize your revenue. So the basic strategy should be to pull a little bit on each one of the slots in order to understand which one of them maximizes your revenue. Cool. So we look at it in a similar way in Offerwall, where we want to give the best task to the user. However, it's a bit different because, let's say, when you pull the lever, it will take some time for you to know whether you succeeded or not. So this is a multi-arm bandit in a delayed feedback settings. where we want to know which task is the most appropriate to the user, but it might take us some time to estimate it. Cool. Let's talk about now the solution exploration. So, small recap, as Daniel mentioned, we are in a big data environment. Most of the data is tabular. It is time series oriented, meaning an impression might come at time t, a click might come at t+1, and eventually a conversion might come at t+10. And again, this is the delayed feedback we are talking about. So where we looked at Kaggle, which has awesome data science project there, and we had a literature review where we found a very good paper by Olivier Chappell, sorry Olivier, from Criteo Labs. I think now he's at Google, last time that I looked at CV, but okay. And we took some ideas out of this paper called Modeling Delayed Feedback in Display Advertising. And one of the points that the paper says is, instead of directly calculating the probability of conversion in case of an impression, split these to two. And first, calculate the probability that the user will click in case he saw the ads. This is P of click. This is the first stage to complete the offer. And only then calculate P of conversion in case a click has already occurred, the conditional probability. And afterwards, just do a multiplication of both to get to the original probability that you are aiming for. And why is it good? Because in that way, we don't try to predict all at once. We are actually using different tools or more appropriate tools for different problems. However, we do need a framework that is able to deal with our needs, which are big data aggregation, machine learning modeling, also in big data, dashboarding, visualization and testing, and of course, debugging and troubleshooting. Cool. So now I will give it to Daniel.
Thank you, Michael. So let's see what we actually chose to implement on our end. So let's see an architecture high-level overview of what we actually managed to do. First, we have the raw events from S3, and a raw event can be, for example, an impression event, a click event, as I described earlier. Then we have Airflow Scheduler, who schedules two processes. The first one is the CTR prediction model, the machine learning model, which tries to predict the CTR. The second one is the conversion prediction model, which Michael described, which tries to predict the conversion probability. Then we unify those two outputs or predictions together, and we store all of those predictions within Aerospike so that the application layer, meaning Offerwall, will be able to take those predictions, query them fastly, and present them to the relevant users in the relevant order. Let's talk about the CTR prediction model. So we used XGBoost as our model due to the fact it has some main advantages. First, it uses Spark. And this is, of course, great based on our architecture and our big data. Second, it knows how to handle missing values within the dataset. I'll elaborate about it in a bit. And third, it knows how to handle great performance with tabular data. So let's see how it works with Databricks. XGBoost for Jade, that's the name of the project that is being constantly updated and stabilized between XGBoost and Spark. We use it, of course, to perform what is known as distributed training. I'll show an example in a bit. It knows how to integrate easily with any Spark ML framework, aka MLlib. And of course, Databricks contains all of the above, which makes it pretty easily and straightforward to use. So what you have to do basically is within the documentation, you can read more about it. However, I added some code samples in which you can have a look as well. First, you'll need to import your relevant libraries. Then you will need to set whatever data processing you do. For example, here we're doing string indexing on some kind of a categorical column. Then you will need to make sure that your data is within a vector data structure, because that's what the ML model, the XGBoost model, expects for it to be. Then you can create yourself your relevant model parameters using a map of key value. Then you can create or instantiate your relevant model and make sure you train it on your dataset. Once it has been trained, and by the way, as you can see here, we're training it in a distributed training, meaning we're training it on 2 specific machines in this case. And once it's done training, you can transform it on your test dataset in order to generate some kind of predictions. One of the great advantages about XGBoost is that it knows how to handle a missing value within datasets. In tree-based algorithms, branch directions, or what is known as default directions, are being learned during the training. You can actually signify XGBoost the specific missing value, in this case -999, as if it was some kind of a missing value. Then once XGBoost will see this value within the dataset, it will know to handle it accordingly within this default direction logic. I'd like to mention another word about MLIP. One of our technical challenges was how to save our models or our pipelines using specifically models that were generated by Spark, specifically as discussed XGBoost for J. We looked for a solution which is actually able to do so. However, it's not that trivial and easy. However, MLIP provides all of the above. Also, Databricks contains great documentation about it. This has made, of course, the process much easier. And I think that that's a great opportunity to share that we wrote a short blog post about how to create this synergy between Spark and MLIP.
Thanks, Daniel. Okay, so Daniel talked about the click prediction, and now we're going to talk about the conversion prediction. So again, very small reminder, conversions / feedback will arrive with a delay, 1 hour, 1 day, 1 week. What we want to do is we want to predict the number of conversions that arrive before they arrive in order to make our model faster and better. For this purpose, we look at this flow as a Poisson process. And a Poisson process is mostly used where we count the occurrences of events that happen at a certain rate, but at random. In the offer wall example, a specific tasks happen at a certain rate, but because each user decides independently whether to start the task or not, it happens at random. So, taking this a step forward, a single event within this Poisson process can be modeled using the exponential distribution, and actually doing the probability estimation using this distribution and a prior P, which I'll elaborate a bit more, is relatively easy. You take the prior P and you multiply it by the exponent of the parameters shown here. So let's talk about the parameters. First parameter is lambda, which is just 1 over the average time to convert from a click. The X is the elapsed time since the click. And the prior P is our past knowledge on the probability to convert. Using only these parameters, we can actually calculate a probability for each user's click to actually become a conversion. Okay, so now we have a model for the click and for the conversion, and we need to orchestrate everything together. We chose Airflow, and this I taken from the documentation. Airflow is a platform to programmatically auto, schedule, and monitor workflows. Our data pipeline is relatively complex, and we have several dependencies that are affecting each other. However, Databricks has an operator which is relatively easy to use. You need to configure some options, but it's not that hard. And also, there is a good documentation about it, so you can just read it. Yeah. So now we will move to the testing and analysis. So our best practices, what we decided to do is to choose one dominant KPI beforehand and two or three supporting ones. We built an analysis tool for analyzing tests, and we ran a small A/B test and later on analyzed it using Databricks dashboard and a scheduler. And let's see how we did it. We read the raw data events using Spark. We aggregated to intermediate results and then saved it on an hourly manner using the scheduler, very easy. We used afterwards SQL, the built-in widgets in Databricks, and libraries like Bouquet to build a one-time dashboard. And again, we use the Databricks scheduler to schedule it every couple of hours. And we actually shared the link with our colleagues so they can look as well. So as you can see here, this is an example from the data pipeline. So you can see that we attached the notebook and we decided on the scheduling and let me and Daniel know if something happens. It's very quick, very easy. I cannot share like the real data, unfortunately, but it's something, one of the tables or something like that, a summary statistics table where you have variant A, B, C, etc. And you can show what KPIs underperforms or overperforms per variant. This is not a statistical test or hypothesis test. This is just a summary statistics table. Another cool thing that you can do is actually plot a histogram from the model prediction distribution. For example, we plotted model A, B, and C, and we noticed that in model A, there is a slight bump between 0.2 and 0.3. And we know from our domain knowledge that this does not make sense that there is so much of them. So we actually took a look at the model and we found out that we had a bug in the missing flag feature that Daniel talked about. We fixed it and it was a very nice analysis. Everyone are saying it, we will say it as well. Exploratory data analysis is crucial. Real world data has so many pitfalls and you need to be extra careful when dealing with it. The second thing is that there is a high chance that the first experiment will go wrong. Actually, our first experiment with the Marshall algorithm, this algorithm, we hit about 25% below the baseline. So it's okay, keep on. Another thing is that late conversions or late feedback equals late results. Don't try to rush into conclusions. And in addition, work is not done once deployment is done. Actually, once we deployed to full scale, we got great feedbacks from sales engineers, account executives, which made our model even better. And post-deployment tools are crucial, especially if other teams are supporting your models like sales engineers or customer support. The thing that we decided to do is me and Daniel prepared a notebook that calls Marshall Investigation Tool. We wrote all of the code, and then we just recorded the session with the relevant engineers. We showed them step by step how to use the tool, and then we released the tool so everyone can clone it and use the same base for analysis, which makes life easier. So a quick summary. We went through a Fiber overview and Offerwall product overview. Afterwards, we talked about our use case, our solution, A/B testing and analysis, and we shared some insights from our own experience. Thank you very much for listening. We really appreciate it.
Thank you very much.